Hey, welcome in a new video. Today we will just apply what we discovered during the previous video about affinities. Don't hesitate to subscribe to the channel to not miss the next video, like and comment this one of course. Today we have a Kubernetes cluster with into it kubectl get nodes. We have 3 nodes into it. I have my own alias, so kget, so it's a classical alias in fact. Get nodes. We can check labels that we have on each node with show labels, and we can add our own label, for example, on this server. So to do that, we can say, okay, kubectl label. So you have annotate, you have label. We have already seen this this part of the CLI label. What we want to label, this is the node, this is not a pod or other things, it's a node. We want to label this node, and we want to set a new label named zone with EU for Europe West 1, just to simulate what you can have inside a cloud provider. And if you check, now we have this label for only this node. So we can set for the other node, for example, the 12, we can set another zone, and we can set the same zone but for the 13 node. Okay, so if we have a look into our kubectl get node with show labels, we have our zone just here. Perfect. And after that, we can make like a little demo about what we discovered during the previous video. So the first thing that we can do is to check the node affinity. So to check the node affinity, I can copy these lines. So it's just an example. You have all in the video description, you have the link, you can git clone the repository to use it. So I can create a dedicated directory just to be clean, and go into it, say node affinity, like here, affinity.yaml, just like here. And after that, we can have a look on what do we have inside this file. So we want to create a deployment name affinity required. The label of the deployment, not the pod, but the deployment is affinity required. We want to have a lot of pods, so 30 pod for this deployment. And for this deployment, we want to create each pod with the label affinity required with a match label based on it to associate the deployment with it. Okay, and so of course we just want to run like a simple Nginx based on latest tag, but it's not really important, this part. And we want to use an affinity here based a part for a match expression based on EU West 1, and we can base it on the host name. So if we apply it like here, we haven't any host name named K0SC5, but we have one server in this zone. So like you can imagine, or we can just begin with another zone, maybe the 15. We have a lot of zone inside our region. I'm not sure that it exists in any cloud provider, but we can do that. And if we do that, like here with node affinity, if we check kubectl get pod, like here, we have a lot of pod, but all pods are not scheduled. And of course, because there is no server, no node with the label equal to the zone equal to EU West 15. So yes, we are locked. All pods are pending, but no pods are running. So it's, yes, the classical things and the basic things in the node Affinity. So if we want to solve it, of course, you can imagine now we want to deploy either, because it's a OR, like we said previously here, it's a OR when we have multiple match expressions or multiple fields. It's not a AND like if we are in the same match expressions. So if we want, we can apply it like here, and we apply it, okay, and we can say, okay, kubectl get pod, and we have a lot of pod in scheduling and in the container creating, and we need to wait a bit. Yes, we have some pod running, okay, can wait, and normally with the rolling we will have at the end, probably, but not probably, for sure, we will have, if I just type wc-l to check, we will have like 31, maybe it's a lot. If I check, yes, my pod. Yes, we have one line for the header, so we can check how many pod is just running, or just with Affinity required. Okay, so we can say, okay, I just want to have Affinity required, like here. 30 pod, perfect. But if we check the distribution of our pod with -o wide, all pods are on the same node. And why? Of course, because there is only one node with the zone equal to EU West 1, and we can't schedule our pod on some other node. Okay, so how to fix it and why we are like that? Because the other condition is based on the host name, but the host name is not, so we haven't any node name K0C5. So how to fix it? So we can either we can change our node zone, or we can say, okay, maybe I can or I want to distribute a little bit my pod some on some other node, like on K0C13, and to do that I can say, okay, K0C13 like here, and if I apply it again, yes, the apply here, I can make a kubectl get pod just here, and like you can see here, our scheduler say, okay, maybe it's not a good idea to spawn all pod on the same node, and I can redistribute a little bit how my pod are spread inside my Kubernetes cluster. So this is exactly what happened. And if we check now the -o, the famous -o wide, what we have some pods on K0C11 and some pod on K0C13. There is no rules. In fact, maybe we are on 50-50 in the spread, but there is no rules. In fact, for that, if we check like here, we have 30. But if we check how many nodes we have on the 11 node, K0 -o wide, let me change it. Okay, we have 15, so it's 50-50, but in fact, it's not really sure. That depends on the scheduler, that depends on some other stuff. So this is the first thing, and if we want, we can check a strict equality. So if I just remove these lines, so all conditions are in the same match expression, meaning we have a hand. That means we need to have in the same at the same time the node K0 C13 and this server need to be in the zone EU West 1. So if I apply it again, so kubectl apply and kubectl get pod, what we will have, that will take a few minutes, I think, to just ensure. Oh, yes, I can just force the thing with kubectl scale deployment, and this is Affinity required deployment, and I want scale. Yes, I want to scale to replicas, set to 0, and I want after that I can check. So yes, it's clean, and now I want to have like 30 pod, and if I check again, all pods are pending. Yes, of course, because there is no node, even if we have a node 13, like here, this node hasn't the label with the required zone, like here. So I can change this label. In fact, I can say, okay, I can set here the label here, and for the 13, I want, in fact, to set the 13 node on the EU West 1 zone, okay, like here. So in fact, first, so either I can just unset the zone, or I can just say, okay, I want to overwrite this label, like here. And now, if I check again, our label for the node 13 is in the good zone, and if I check again, now we have all pod will be in a running status. Okay, so we are quite good for the node affinity. I hope that you understand that. Now we can test the pod affinity. So the pod affinity, first we will test like a bad settings or not regular settings. This is not a real use case, in fact. So the first thing, I can delete the deployment, deploy the affinity required, like here. And now we will have, yes, a clean namespace. Okay, and I can set pod affinity, a new deployment with pod affinity, like here. And if I put that, what do we have into it? We have affinity required, again, deployment, but take care inside this deployment, or I can say, okay, I can say here we have front end. So we have a front, so it's a front end, no, it's a back end in this example. Maybe it's better to say back end for now. It's a back end. So imagine that we have back end here, and we have so that means that here with the template of pod, we will have all pod with the label app backend. Okay, I want to set an affinity based on the pod affinity with a strict condition, so required, based on the label selector and based on the match labels app backend, meaning that all pod, so we can say like individually, all pod check if there is some other pods with the app backend and will be deployed on the same topology key, meaning the topology key here is set to the host name, meaning that at the end all pod want to be on the same host name like the other pod with the app backend. So normally at the end, what we will have all pod backend on the same host name, in fact, because they want to be close and based on the host name. So if we just, if we just apply it with pod affinity, what we will have like here our 30 pod, and if we check dash o wide, like here, we'll have all pod on the same node. There is no condition on the pod name, meaning that the first pod will be scheduled on the pod on the node key 0 C13, and the other node just after that check the condition based on the app label backend, and there is only one pod on the node K0 C13 inside our cluster, so all other nodes check the condition to be closed and on the same host name. This is only that. If we, for example, if we kubectl scale down, we can test to scale down our backend deployment with replica set to 0, equal to 0, like here. So we just can wait a bit. Now we have nothing into the pod, and if we set like here, maybe 15, maybe, or probably, oh no, we are on the same node, but it's not sure. In fact, you could be on another node, but with all pods inside the same node. Okay, so it's like quite interesting. What we can do, we can use the anti-affinity. So I can just remove kubectl delete deploy, and we want to remove the deployment in the backend. Okay, like here. Yes. And if we check, yes, no pod into it. And if I check again, I can test the anti-affinity. So it's here, anti-affinity. Normally it's like that. And if we check, and if we apply exactly the same thing, yes, apply like here, kubectl get pod again. And what happened? It's really interesting. It's beginning to be interesting, really interesting. What do we have into it? We have only, so we have a lot of pod in pending status. But if we check here, we have only 3 pod up and running, okay? And each one are in a different server, meaning that there is a spread, in fact, of our pods inside our cluster based on the host name, and we use the anti-affinity. So that means that it's exactly the opposite that we did just before. We want to just deploy each pod on a topology based on host name, and only on host name without a pod with the app backend. So the first pod can't find on the host name another pod with the app backend label, so he can go on it. But the second one just check inside the cluster. But in fact, it's really the scheduler who did that. But the second pod arrived to be deployed inside our cluster. But for example, for the 11 node, we have already a pod, so we can only go on the 12 or the 13 pod, and so on. That means that when we will have the second pod on the 12 node, the third pod will be scheduled, but only on our 13 node, because we have only we have only 3 nodes inside our cluster. And if, for example, we have 10 nodes inside our cluster, we will have 10 pods only. This is why we have a lot of pending pods in our case. Okay, so this is really interesting to have it. It's not a daemon set, because if you really want to deploy each node and to ensure to have a pod on each node, it's really better to use a daemon set. It's created for that, but in this case, it's really interesting to do that. And if I don't want to have a pending pod, I can set the number of replica based on the number of nodes, like here. And if I apply it again, now I will have this kind of thing. So it's really interesting, this kind of a situation. The other thing, and the other test that we can do is to test another deployment. Okay, but this deployment, we want to take care about this deployment. This is like we already saw in the previous video. For example, we want to keep the front end close to the back end, like here. So how to do that? We want to use the pod Affinity and front end.yml, like that. And yes, I can remove it. It's not, it's just a comment. So we can imagine that we want to deploy our front end close to app backend application based on the label. So here we are on the front end. So I can change the name of the deployment here, front end, and we can change it here again. We can say, okay, I want to have only three pods, sorry for the moment. We want to have affinity, and because we want to be close, we want to say, okay, we want to have an affinity based on the zone and on backend, meaning that the front end with pod with label app front end will be distributed inside our cluster on a topology key. So this is the zone where we want to be in the same zone like another application based on the label app backend. So app backend, this is exactly what we deployed just before. So we have our app backend here. So if we want to spread it on the zone, I can check what we have right now. So kubectl get node, show labels, not value, labels, like here. So we have EU West 1, so we can set EU West 1, so it's a zone, it's a backend, but yes, our backend are distributed on all zone right now. How to mitigate that? I can say, okay, it's a pod affinity .yaml. I can say I want an affinity, in fact, yes, could be better. I want to have an affinity on a label selector and on host name. That means that we just, like we roll back, in fact, what we did. So it's pod affinity.yml. If I check, normally we will have all our deployment on the same node. So normally it's good. If I check 3, yes, it's a backend, okay. And if I check why we have a pending node, normally no. I can scale backend and set to 0 just to be quick, in fact. And I can say, okay, I want to have 3 backend server. All will be on the same node because we want to, and we use the topology key based on a host name, okay. And now I can deploy. Our new and our front end. So this is pod dash front end. I can apply. And what do we have? We will have 3 front end because we set it inside the manifest, the YAML. Okay, it's up and running. If I check how we are just here, all, so not all, in fact, yes, it's normal. We have front end on only the 11 node and the 13 node. And if I check, so we can check the labels of our nodes. What do we have? We have two nodes inside the same zone here, so the 11 and the 13, and we say, okay, our backend are deployed on the 13 node. The 13 node is in the zone U West 1, and after that, for our front end, what happened? The scheduler just checked where is the backend, because where is the app backend labeled, where are pods with the app backend label. But in our case, so this is not this one, this is this one. For the front end, we say, okay, we want to have a topology based on the zone. So that means that we can just deploy our front end regarding the scheduler only on the node 11 and the 13. And we can imagine that now we want to change directly right now the label of the node 13, for example. So if we want to change this label, we can apply the label. Where is the label? Okay, I can check label. So not this one, and I can say, okay, now I want to change it to West 3, like here. So it's quite good. In fact, we have 1, 2, 3 for our node, and if we check what happened, there is no change into our pod. Okay, so now I can say, okay, dash O wide, and we kept front end on 11 and 13. So normally, regarding our setting inside our deployment, from front end deployment, we can't and we must to not have, we mustn't to have a pod, a front end pod here. So why we have it? This is only because remember that inside the Affinity we use the during scheduling. So when we change the label of our node, the pod and pods are already deployed, and in fact the scheduler are not applied again. So this is not during the scheduling, in fact, because our pods are already there. So it's really important to know that, because like you saw before, just if we change like a hot change directly inside our node to change directly the label, but that can be another settings. If all pods are already deployed, there is no change in this case, because the scheduler are not just used to deploy something, in fact. So just like a demo, we can check again now to like redeploy again the front end. How to do that? I can use the scale again. So kubectl scale deploy, and I can deploy. So I want to just change the number of replicas. I set it to 0. Like I say, okay, I just want to remove all pods, all front end pods, like here. Now I will set it with 3, like previously. Okay, and if I check it again, I will have all on the 13 node, because when I just scale down and scale up, I reactivate, I reuse, I go through, and I use the scheduler just to schedule our pod, and this is why now our conditions are checked. So that's it for today. I hope this video and this demo is really interesting for you. There is a lot of other things to know based on the taint thing, or classical topology based on node name or stuff like that directly inside the pod, to try to mitigate or to ensure that your pods are deployed only at one place. For example, taint, like here, the scheduler is just based on the pod deployment, but if you want to ensure that there are only some specific pods on some nodes, you can set what we named a taint on a node, and only a pod with this taint will be accepted by the node. This is really a way to enforce the condition, but we will see it later. That's it for today. Thank you for following this video, and see you in the next one. Bye bye.